your cameras, but whenever I ask you, you have to give your response. Today we will be discussing about socket and spigot joint, that which I have shown you over here. This is socket and spigot joint. Okay, we are going to derive this one. If not, we are going to design this one. Okay, here, if you see the question clearly, here we have to draw and design and draw a quarter joint, support load varying from 40 kilonewtons. That means here P value is given as, load is given as 40 kilonewton, which implies 40 into 10 to the power of 3 newtons. And the material used in carbon steel for which the following allowable stresses may be used. This is made up of carbon steel and allowable stresses are being given over here. Tensile stress or compressive stress, that is normal, is equal to 65 megapascal. That is, tensile stress or compressive stress is given as 65 megapascal, which is 65 Newton per millimeter square, which is 65 Newton per millimeter square. Shear stress, tau value is given as 70 megapascal, thereby 70 megapascal, which is 70 Newton per millimeter square. Crushing stress, sigma C is equal to, crushing stress is given as 85 megapascal, thereby 85 megapascal is equal to 85 Newton per millimeter square. Here if you see this, here it is consisting of sleeve and socket and spigot joint is consisting of 4 parts. First part is shaft, this is shaft, this is shaft. Okay, this is shaft, this is shaft. First part is shaft, first part is shaft. Okay, second part is socket, second part is socket. See here, this one is socket, this one is socket. Here, this one is socket, this is socket. Okay, third one, that is socket. Third one is spigot, third one is spigot. Socket is a female component and spigot is a male component. This is spigot, this is spigot, this is spigot. That is, third one is spigot. Okay, and the last one it is, quarter, and the last one it is quarter. This is quarter, this is quarter, that is quarter. Okay, these are the 4 components that this specific joint consists of. Okay, thereby we have to design these 4 components for this particular joint. Design these 4 components for this particular shaft joint. Okay, if you see, shaft is consisting of only single diameter D, whereas socket is consisting of D1. See here, D1. This is the external diameter D1, external diameter D1, and also just a minute. Okay, this is consisting of D and this is consisting of D1. Socket is consisting of D1, and if you see clearly, socket, this also comes under socket only, that is D4. D4 will be also coming under socket only, D4. And D2 is nothing but internal diameter of socket. Okay, whereas spigot we are having D2 and D3. D2 we are having for spigot and D2 we are having for socket. For socket, D2 is internal diameter, whereas for spigot, D2 is external diameter. Okay, you have to be clear. And D3 is nothing but collar diameter. D3 is nothing but collar diameter. And for quarter, it is B comma T. B comma T. Okay, B is nothing but width of the quarter, T is nothing but thickness of the quarter. These are the parameters first we have to find out for designing of socket and spigot joint. Socket and spigot joint. Okay, for the first step, for the first one, we will be finding out for the shaft. As a first one, we will be finding out for the shaft. That is diameter of rod. If not, you can call it as diameter of shaft. Diameter of shaft. Okay, that is P is equal to pi by 4 d2 square into shear stress. Okay, here if you see for this P is perpendicular in cross section, perpendicular for area of cross section of the particular shaft. Thereby area of cross section is pi by 4 and P is perpendicular thereby shear stress. In this particular formula, we know what is P, we know what is shear stress. The thing is that we have to find out D value. The thing is that we have to find out D value. D is nothing but diameter of the shaft. Thereby, D is equal to 4P by pi into shear stress. 4P by pi into shear stress. Just substitute the values, that is 4 into 40 into 10 to the power of 3 by pi value. Pi value we have in calculators. Shear stress is equal to 65. Okay, if you find out the answer, you will be getting, can anybody give me the what is answer for diameter of the shaft? What is the answer for diameter of the shaft? D is equal
One,
to
1 second.
28 millimeters. Just verify whether I have written the correct answer or not. Just verify whether I have written correct answer or not.
27.6 correct.
Okay. Next. Second, as a second component, I think we have discussed about shaft. Let us discuss about socket and spigot. These two we have to find out. Okay, now let us see about spigot. Let us see about third one, that is spigot. Then we will be going for a socket. Okay, first let us go for spigot. Then we will go for socket. For in this spigot, we have to find out D2 and D3. Okay, D2 and D3. Okay, let us find out that. Okay, here we are going to find out diameter of spigot, and in single I cannot find out diameter of spigot. Okay, it is having some continuity, that is quarter thickness. Quarter thickness. Okay, diameter of spigot and quarter thickness. That means at this portion I am going to find out. I think everyone can see that. This is the portion. Black colored portion is the portion I am going to consider now. Black color portion is the portion that I am going to consider now. Okay, black colored portion is the portion that I am going to consider now. Here D2 is an internal diameter for socket. D2 is an internal diameter for socket. If you see the figure will be something like this. The figure will be something like this. This is the area of cross section that I am going to consider. Hatched portion is the area of the portion that I am going to consider. This is D2 and this is T value. If you see in this view, and if not in this here, from this figure I have drawn this one. Okay, here force is equal to, formula for force is equal to, okay, here that is pi by 4 d2 square. That means I am getting total area of cross section pi by 4 d2 square. In this I have to eliminate this rectangle, that is this slot I have to eliminate, that is d2 into t. It is in the form of rectangle, thereby d2 into t. Okay, as force is perpendicular to this area of cross section, thereby it is multiplied with shear stress. It is multiplied with, sorry, normal stress. Okay, in this particular formula, we know what is P, we know what is T, sigma, but we don't know what is D2 and we don't know what is T. Two unknown variables. When there are two unknown variables, you must assume one variable. When there are two unknown variables, we must assume one variable. Thereby, I am just assuming T is equal to D2 by 4. This is just an assumption. Okay, this is just an assumption, that is T is equal to D2 by 4. Okay, now let us solve this. Substitute T is equal to D2 by 4, thereby P is equal to pi by 4, pi by 4 d2 square minus d2 by 4. Instead of t I am writing d2 by 4 into d2 into sigma value, okay, here let us take d2 value as a common, thereby d2 is equal to p by pi by 4 minus 1 by 4, which is multiplied with shear stress, Just let us find out the answer by substituting the values. Thereby d2 is equal to p value. P is nothing but 40, if I am not wrong, 40 into 10 to the power of 3 by pi by 4 minus 1 by 4 into shear stress. Shear stress value is nothing, normal stress value is nothing but 65. Just a minute. Okay. Let us continue. Now just substitute the values here. Shear, normal stress value is I think 65. Can anybody give me answer for D2? D2 value answer. D2 value answer.
40, sir.
40? Just 40?
Yes,
Everyone,
sir.
everyone unmute your mics. I have to. Everyone unmute your mics. Only 31 has unmuted. What about remaining? If not, switch on your cameras. If you cannot unmute, switch on your cameras. Switch on your cameras, everyone. Everyone, switch on your cameras. Switch on your cameras. If not, I will mark absent. What about 310? Why you are not giving response? Okay. Here, D2 value is, according to my calculations, it is 34 millimeters. Okay, if D2 value is 30, I think everyone can see my screen. Is that correct or wrong?
Yes.
Okay, okay. 34 millimeters. If D2 value is 34 millimeters, you can find T value also. T is equal to 34 by 4. It is nearly 8.5. Okay, nearly 8.5. See here. Step number 3 is verification. Step number 3 is verification. Here it is verification. Okay, I have given you a design procedure. In that design procedure, step number 3, that is formula number 3 is verification. That formula is P is equal to D2 into T into sigma C. P2 into D into sigma C. Okay, see, in the previously I have drawn a figure, that is, the figure is something like this. Here I have shaded, here I have shaded. Okay, here you are considering external component. Let us consider about crushing. If you consider about crushing, this is the area of cross section that you have to consider. This is the area of cross section. Yellow colored portion is the area of cross section that you have to consider. That area of cross section is D2 into T. Okay, here as quarter is placed in this slot, it will be under crushing. Thereby it is multiplied with crushing. Thereby it is multiplied with crushing. Okay, now let us find out. We have P value, we have D2 value, we have T value. Even we have sigma C value also. As it is verification, we will find out sigma C value. That is, sigma C is equal to P value is 40 into 10 to the power of 3 by 34 into 8.5. If you find out the answer for sigma C is equal to, you will be getting 138.5 something else like this, which is greater than the value given in question, which is the greater than value that is given in question. Hence, our design is not safe. Design is design is not safe. Okay, so we have to find out our d2 value and t value again. If this is satisfied, we can go with our d2 value and t value which we have obtained from here. Okay, but unfortunately these values are not satisfying our answer. These values are not satisfying our answer. So again we have to find out d2 value and t values. That is by using same formula, 40 into 10 to the power of 3, by using same formula is equal to d2 value. We don't know what is d2 value. T value we know in terms of d2, that is d2 by 4. Sigma c value should not be exceeding 85 Newton per millimeter square. 85 Newton per millimeter square. 85 Newton per millimeter square. So just find out d2 value. Thereby d2 is equal to 4 into 40 into 10 to the power of 3 by 85. I think it is d2 square. If you solve this, you will be getting d2 is equal to 44. d2 is equal to 44 and t value is equal to 11. If it is 44, t value will be by 4, thereby 11. Okay, these are your new values. You should not consider these values because it is not satisfying our crushing stress. Now, whether when d value is satisfying crushing stress, it will support any of the stresses. If you not, you can verify with your second formula, no problem. Okay, here I already told you, no need of verifying these values. Okay, that will definitely satisfy your second formula, no need of verification. Okay, now we have gone for our third formula also. Now we should be going for our fourth forms. That is fourth formula is outer diameter of socket. Outer diameter of socket. Outer diameter of socket. See here, d1 is the internal diameter and d2 is internal diameter and d1 is external diameter. If you want, you can see clearly in this figure. See here, d2 is internal diameter, d1 is external diameter for socket. Okay, whereas d2 is external diameter for spigot also. d2 is external diameter for spigot but internal diameter for socket, and d1 is internal diameter for socket. This is the small end. And also if you consider over here, this is also coming under socket only. If you see this d4 over here, this is also coming under socket only. This is also here this is also comes under socket only. Okay, this is also comes under socket only. Okay, we will discuss about this end later. Let us discuss about d1 and d2 now. Okay, let us discuss about d1 and d2 now. Okay, if you see the figure, that figure will be something like this. Only the area which I am going to hatch now is that we have to find out. This area is that we have to find out. Only the area which I am going to hatch now is that we have to find out. This is the area that we have to find out. Remaining area is not necessary for us. Okay, that is, if you write the formula for that, it will be pi by 4 d1 square minus d2 square as per the whole. Okay, and it will be taken out from minus d1 d2 into t. This one also should be neglected and this one also should be neglected. Okay, for that it is d1 minus d2 into t, which is multiplied by thickness. Okay, as the stress is perpendicular, it will be multiplied with normal stress, which is equal to force. Now, in this particular formula, we know what is p value. In this particular formula, we know what is p value. We know what is d1 value. We don't know what is d1 value. We know d2 value. We don't know what is d1 value. We know d2 value. We know t value, and we know shear stress value. The thing is that we have to find out d1 value. This is only a bit complicated while comparing with all calculations in this particular problem. Okay, let us see how I am going to solve this. Here, P is equal to 40 into 10 to the power of 3, which is equal to pi by 4 d1 square. Okay, this is what we have to find out. Minus d2 square. d2 square will be written as 44 square. Minus d1 is that we have to find out d1 into t. Minus d2 is nothing but 44 into 11 whole multiplied with normal stress is nothing but 65. Normal stress is nothing but 65. Normal stress is nothing but 65. Just make it simplify. Make it simplify. That is here. First I will write pi by 4 d1 square, this one pi by 4 d1 square minus pi by 4 into 44 square minus d1 into t. Minus into minus it will become plus, minus into minus it will become plus 44 into 11. Okay, it should be multiplied with 65. This one also should be multiplied with, if not let it be very simple, let it be very simple. Okay, whole multiplied by 65. So I will write equal to 40 into 10 to the power of 3. As it is multiplication over here, I will bring it as division. I will bring it as division. Okay, just I will rewrite this equation, that is 44 into d1 square minus d1 into t. Here d1 into t I am writing over here, d1 into t. Now this component, that is minus pi by 4 into 44 square plus 44 into 11 minus 40 into 10 to the power of 3 by 65 is equal to 0. Okay, this is in the form of ax square plus bx plus c is equal to 0. That is, this is a, this is a, this is t. Here I think we know what is t value. If you still simplify it and rewrite the equation, that is, instead of t I will write it as 11 d1. T value we know. Okay, now this is going to be your b value. This is x square, this is x, this total term is going to be c. Total term is going to be c. It is in the form of ax square plus bx plus c. In your calculators, go for shift mode. Shift mode, in that you can see equations. In equations, ax square plus bx plus c form will be there. Just select that form, substitute a value, b value and c value, and press equal to. Thereby you will be getting d1 is equal to 54 millimeters. D1 is equal to 54 millimeters. If you see here, I have designed D2, I have designed D1. Now I should design D4 and D3. Only these only these two parameters are left over, and also B value is also the thing that we have to find out. Okay, let us find out them now. Okay, that is formula number 5. Formula number 5, that is diameter of socket. I am writing it as collar because bigger end I am representing it as collar. Okay, that is P is equal to d4 minus d2 into T into shear stress. Let me show you. Let me drag this figure. Okay, let me show you. Now I am going to consider this biggest portion, this one. This biggest portion is that I am going to consider. This is the biggest portion that I am going to consider. This is the biggest portion that I am going to consider. This one. This one is the biggest portion that I am considering. Okay, if you see, the external diameter is d4, internal diameter is d2. External diameter is d4, internal diameter is d2. This is nothing but this is d4 and this is d2. D4 and D2. Here there is a slot. Here there is a slot. Okay, I am just finding the area of cross section for this. Finding the area of cross section for this here. Given you the hatching, that is the area of cross section that I am going to find out. This is D4. This is D2. D4 minus D2 is nothing but you will be getting D4 minus D2 is nothing but you will be getting this ring. In this ring, I want only this area of cross section. Thereby, just I am multiplying it with respect to T value. I am multiplying with respect to T value. You will be getting only this area of cross section. into, as it is a crushing stress, I am writing over sigma over here. I am writing sigma c over here as it is a crushing stress. Thereby, here we know what is p value, we know what is d2 value, we know what is t value, and we know what is sigma c value also. We have to find out d power 4. Thereby, sorry, d4 is equal to p by t into sigma c plus d2. That is d4 is equal to p is nothing but 40 into 10 to the power of 3 by t is nothing but 11 sigma c is nothing but crushing stress is equal to 85 newton per millimeter square plus d2 value is equal to d2 value is equal to 44. Just calculate this value, you will be getting d4. d4 is equal to 87 millimeters. d4 is equal to 87 millimeters. Okay, from there we can find out d7. From there we can find out this value also. Okay, now, let us find out for the other components also, that is diameter of spigot collar, that is here, this one. If you see, this is spigot collar, D3, that is what we are going to find out. That is diameter of diameter of spigot collar, okay, that is p is equal to pi by 4 d3 square minus d2 square, which is multiplied with crushing stress, just a minute. Okay, here we know what is p value, we know what is d2 value, we know what is sigma c value. The thing is that we have to find out d3. d3 square is equal to 4p by pi into sigma c plus d2 square, which implies d3 square is equal to 4 into 40 into 10 power 3 by pi into sigma c is nothing but 85 plus 44 square. 85 plus 44 square. Okay, if you find out a d3 value, thereby d3 is equal to 51. d3 is equal to 51. Okay, by this we have found out almost all terms that are being related with respect to socket and also spigot. Let us find out for quarter. Okay, here width of quarter, thickness of quarter we have found out already. Width of quarter is P is equal to 2B into T into shear stress. Okay, that is here we know what is P value, we know what is T value, and we know what is shear stress value. The thing is that we have to find out B value. B is equal to P by 2T into shear stress. That is, P is nothing but 40 into 10 to the power of 3 by 2 into T value. T value is nothing but 11. Shear stress value, it is already provided in the question, that is 70 megapascal. 70 megapascal, nothing but 70 Newton per millimeter square. Thereby, B value is equal to 26 millimeters. B value is equal to 26 millimeters. Okay, this is up to step number 7. Okay, let us go for step number 8. Step number 8, that is socket and collar thickness. And socket collar thickness. Socket collar thickness. Socket collar thickness. Okay, in order to find out socket collar thickness, we have a formula, that is P is equal to 2 into D4 D2 into C into shear stress. Here we know what is P, we know what is D4, we know what is D2, and we know what is shear stress value also. We don't know what is C value. Thereby C is equal to P by 2 into D power 4 D4 D2 into shear stress, which implies 40 into 10 to the power of 3 by 2 into D4 is nothing but 87, D2 is nothing but 44, into shear stress is nothing but 70. Thereby, C is equal to 7 millimeters. C is equal to 7 millimeters. Similarly, step number 9. Step number 9, if not formula number 9, if not design procedure number 9, anything you can call it as. That is distance from end of this slot to end of rod, distance from end of the slot to end of the rod, that is P is equal to 2 into A into D2 into shear stress. In this formula the only term that is unknown is D value. Only term that is unknown is D value. Thereby A value, thereby A is equal to P is nothing but 40 into 10 to the power of 3 by 2 into D2. D2 is nothing but 44 millimeters into shear stress, that is already provided in the question, that is 70. Thereby A is equal to 7 millimeters. If you see here A and C value, both values we got as common. Both values we got it as common. Okay, and the 10th one, last but one, that is 10th one, that is Spigot collar thickness. Spigot collar thickness. Spigot collar thickness, that is P is equal to pi d2 T1 shear stress. Here we have to find out T1 value, thereby T1 is equal to 4 into 40 into 10 to the power of 3 by 40 into 10 to the power of 3 by pi into D2 is nothing but 44, shear stress is nothing but 70. If you find out this value, T1 is equal to 5 millimeters. The last one, it is 11th one. 11th one is nothing but length of the quarter. Length of quarter. For length of quarter, we don't have any derivation. Just it has a formula, that is length of the quarter L is equal to 4 into diameter of the shaft. Thereby length is equal to 4 into diameter of the shaft is 28 millimeters. Thereby L is equal to 112 millimeter. 112 millimeter. This is the design procedure, if not design values, for finding out our sleeve and spigot and quarter joint. Spigot and quarter joint. This is the figure. If you see the figure, just check for the values. Check for the values. Here, if you check for the values, we have to find out D1 value. D value, we have found out D value, that is shaft. For shaft, we have to find out D value. We have found out D value. For spigot and socket, we have to find out D2 value. For spigot, we have to find out D2 value. We have to find out D3 value. And also thickness of this collar, that is T1 value for this spigot, we have to find out. We have found out this. Okay, and also here this A value, that is end to the slot value, A value also for the socket we have found, spigot we have found out. Now socket, for socket we have to find out in external diameter from one end, that is D1 value. D2 value is nothing but internal diameter. D3 value is nothing but socket collar diameter. Okay, after finding socket collar diameter, we want to find out here this E value that also belongs to socket collar only, that is E value, and also C value. This is C value, from where it is having some slot. Okay, after that we should going for quarter. For quarter we have to find out length value, we have to find out width value, that is B, and we have to find out thickness value T. Width value, thickness value, and length of the quarter. These are the terms that we have already found out in this particular problem for designing this particular figure. Okay, you have to draw this figure you have to draw this figure and you have to write all these procedure in order to get 10 out of 10 marks. Okay, am I clear? Are we clear? Do you
Yes,
have
sir.
any doubts up to here? Any doubts up to here?
No, sir.